implicit differentiation. So some of these might be familiar. I don't know where it is. There it is. Some of these might be familiar for you guys in some of your other math courses. Okay, so one, we have circles. Okay, and that is going to look like x squared plus y squared is equal to r squared. Okay, we also have ellipses. And this will be x squared over a squared plus y squared over b squared is equal to 1. Remember, an ellipse is like a flattened out circle, essentially. There's a video on the internet of this guy. He can draw a perfect circle. You guys seen it before? He like, just like, it's funny because he like warms up his arm.
Oh yeah.
And then, and then he goes up to it and he's like, and it's just like absolutely perfect. It's actually pretty funny. Yeah, we can watch that at the end of today. Okay, we have hyperbolas. So that is going to be x squared over a squared minus y squared over b squared is equal to 1. So that might look something like this. Okay. And then lastly, we have our parabolas, which you guys are probably most familiar with.
Parabola.
Parabola. Let me spell it right. Parabola. P-A-R-A-B-O-L-A. Even though you just sounded it out, I couldn't spell it properly. And this is going to be y squared is equal to 8x. Okay. And with the, like in comparison to hyperbola, we'll only like have one usually.
What's the one going? So parabola is that the one to the side? What's the one going up?
Oh yeah, so parabola. Yeah, so this could be in like any direction, really.
Okay.
Yeah. But we're only going to have one of them. Typically, we'll have hyperbolas in pairs.
Okay.
Yeah. Good question.
And hyperbolas could be this way too.
Yep. Yeah, exactly. Good questions. Okay, so these are just some graphs that will use implicit functions. Okay, so now we're going to kind of blend a little bit of our implicit differentiation with finding the slopes of tangent lines, right? So remember, anytime that we had a function, if we were to take the derivative of that function, we could find the slope of that function at, if we were given 2 points, right? You guys remember that? I think that was back in beginning of December, right? So that might have been a while ago. Okay, but that's okay. So first thing that we're going to do here, we'll find the derivative of this function here, okay? So x squared over 5 minus y squared is equal to 1. Okay, so we can rewrite this guy here just to make it a little bit easier for us as 1 over 5 multiplied by x squared minus y squared is equal to 1. Okay. Now we will take the derivative of this. So 1 over 5 multiplied by the derivative of x squared with respect to x minus the derivative of y squared with respect to x equal to the derivative of 1 with respect to x.
So if there's a constant in front, you just leave her?
Yes.
Right.
Yeah, because this is like the coefficient that is attached to the x squared.
Okay.
In this case, on this side over here, we will take the derivative of that because it's just the constant, right? It's
okay.
Yeah. Good question. Okay, so now we can just differentiate these. So derivative of x squared would be 2x. And remember, when we differentiate x, we do not have to put in dx over dx because it will just cancel out. Okay. However, when we're differentiating y, we do have to make note that we did that. So the derivative of y squared would be 2y multiplied by y prime. Okay, and then the derivative of 1 is going to equal 0. So I'm going to combine these. We'll have 2x over 5 minus 2y multiplied by y prime is equal to 0. Now we need to get our y primes all on one side of the equation. Okay, so because this is a negative 2y y prime, I'm just going to add that to both sides. Okay, those will cancel. And then we will be left with 2x over 5 is equal to 2y times y prime. We want to isolate for y prime. So we will divide by 2y, both sides. Those will cancel. Oops. So then we get y prime is equal to 2x over 5 multiplied by 1 over 2y. Same thing as dividing, right? So we'll get 2x over 10y, which we could reduce to 2 divided by 10 would be 1 over 5. So we get x over 5y. So this is the general slope for our function at any point, right? We can, so now that we are given, so we jump back up to the top, we are looking for the slope at 5 and 2. So we can just substitute in x for 5 and y for 2. So y prime at 5, 2 is equal to 5 over 5 times 2, which is equal to 5 over 10, which is equal to 1 over 2. So m at 5 and 2. Good.
I have a
But,
question.
yep.
So does y prime and m, you can just interchange them? Or by m, do you just mean slope?
M is slope.
Okay.
Yeah, so when we find y prime, or when we find the derivative of any function, that will tell us the general equation for the slope of that function. And then when we substitute in our points, our x and our y, that's when we will get our value, right?
Do we have to do a general equation?
Not in this case.
Okay.
Yeah.
We would have to ask for us to do that?
Yeah.
Okay.
Yeah, so if like this question, it just said, just find the slope of the tangent through this point.
Okay.
So take the derivative of the function and then substitute in your x and your y values, and that's it. Okay? All good? Okay. So same kind of question here. So we're going to find the equation of the tangent line. So in this question, Quinn, we will have to find the equation. Okay. For the relation 3xy squared plus 6x squared plus 4y is equal to 5. And we are given a point 1 and negative 1. So deriving this, probably simple enough, right? That's just going to be 12x, right? Deriving 4y would just be 4. What about this guy? What do we have to use for this? Yeah, the product rule. Excellent. Okay, so I'm going to do that first because it just makes it a lot easier to like substitute it in after. Okay, so we will do 3xy squared product rule. Okay, so we will let our u can be 3x and our v will be y squared. Okay, so if we find u prime, that will just be 3. Sorry, remember the product rule is y prime is equal to u times v prime plus v times u prime. Okay, so u prime is just 3. V prime will be 2y. What do I need to include if I'm differentiating y?
Y prime.
Yeah, y prime. Excellent. Okay, so y prime is u multiplied by v prime plus v times u prime. So we'll just put those together. So y prime is equal to u. So 3x times v prime. So 2y times y prime plus v, which is y squared, multiplied by u prime, which is just 3. Okay, and we can expand or distribute those in. So y prime, we'll get 3x, 3 times 2, so we get 6xy y prime plus 3y prime squared. Sorry, that's a 2. I knew I should have made that better when I wrote it. Okay, so that is our derivative of 3xy squared. Okay, so now when we are like adding those up, when we're differentiating those and isolating for y prime, we can substitute those in right away. Okay, and if that didn't make sense, just let me show you what I mean. Okay, so our function again is 3xy squared plus 6x squared plus 4y is equal to 5. Okay, so now we will take the derivative of each term. So say derivative of 3xy squared with respect to x. So we already found this one, right? So I'm just saying that we're doing that because, you know, proper notation and stuff, right? So then we'll also do plus the derivative of 6x squared with respect to x plus the derivative of 4y with respect to x is equal to the derivative of 5 with respect to x. Okay, so the derivative of 3xy squared is 6xy y prime plus 3y squared. We already worked that out. So we will get 6xy y prime plus 3y squared plus the derivative of 6x squared, so 12x. And remember, when we differentiate x, we do not need to include the dx over dx. Okay, so plus the derivative of 4y will just be 4 multiplied by y prime is equal to 0. what's our next step? Yeah, awesome. Okay, so we want to isolate the y primes, right? Yeah, so let's get everything that does not have a y prime to the other side of the equation. Okay, so we will subtract 3y squared and we'll subtract 12x, right? Because we're isolating y prime. Y's are fair game. We don't really need those to be on the same side. Okay, so these cancel. And then we're left with 6x y prime plus 4y prime is equal to negative 3y squared minus 12x. So now let's just factor out our y primes. So if we take y prime out of the first one, we'll be left with 6xy plus 4. Can we simplify or factor this guy right here? -3? Yeah, excellent. Y squared plus 4x. Okay, and now we will just divide by our 6xy plus 4. Cancel. -3 y squared plus 4x over 6xy plus 4. So what have we just found? Yeah, the derivative of it, right? So, and in other words, we have found like the general equation for the slope of this function, right? So now let's find the slope at 1, 1. Okay, so then we can just substitute in our x's and our y's. So y, -1 squared plus 4 times 1. 1 multiplied by -1, 4. Okay, so we have -1 squared, which is +1. 4 times 1 is 4. And over here we have 6 times 1 is +6 multiplied by -1 is -6 plus 4 is -2. Okay. -3 multiplied by 5 over -2. Y prime is equal to -15 over -2. So 15 over 2 is equal to m. Or 7.5 if you're a numbers guy person.
I did it. I converted it to decimals, and then I figured since it's rise over on, I convert it back.
Nice.
I have a question.
Sure.
I got lost at the start. Why did they do the product rule at the beginning?
Okay, yep, good question. So Okay, so for 3xy squared, because we have, we're multiplying these two variables, right? We can't just like take the power rule of it because we have a u and a v. So we need to differentiate this here using the product rule because they're being multiplied together, right? Like we're just so between 3xy squared and 6x squared, we're adding those two, okay? But if we're taking the derivative of 6x squared, we can just use the power rule, okay? Really good question. Yeah, anytime that you have like two variables beside one another, that is a really good time to do the product rule, okay? Excellent question. Okay. So for this one, we're actually finding the equation of the line. So we know m, right? And remember, we're still at 1 and -1. Okay, so y is equal to mx plus b. We know m. X is 1, y is -1. So let's just substitute those in. So we have -1 is equal to 15 over 2 times 1 plus b. 15 over 2 multiplied by 1 is just 15 over 2. So we will subtract 15 over 2 from both sides. That will cancel. So -1 subtract -15 over 2. So remember, -1 is -2 over 1 is a fraction. So b is going to equal -17 over 2. So we found b, we found m, and now we can put our equation in standard form. So let's do. So we have y is equal to mx plus b. So y is equal to 15 over 2x minus 17 over 2. Okay, remember when we are putting our answer in standard form, we do not want fractions. And we also want a positive coefficient in front of the x. So let's get rid of our fraction. So we multiply both sides by 2. We can get rid of our denominators. And we will have 2y is equal to 15x minus 17. And then we will get everything onto one side. So subtract 2y from both. And then we have 0 is equal to 15x minus 2y minus 17. Okay. So let's leave it there for today. Goodbye.